Hello, today I will show you how we can calculate an object's dimensions and geometric parameters like angles, perimeter, and area using OpenCV. First, we will prepare the video setup for our camera. Next, we will create a method to select objects by color. This is how we will identify our object's corners. After that, we will continue with corner selection by creating a mask for our color. We will create contours and centroids. Centroids will represent our triangle's corners. Next, we will use math for the calculation of the triangle's angles, edge distances, perimeter, and area. We will finish by adding the scale to our measures, making our measures precise. The bonus part will be adding the zoom window to make the scale defining process easier. Let's go into the code. We will start by preparing the video setup. It's very basic, so I just go through the code and explain the main parts. First, we need to have the OpenCV library installed. Make sure to do that, and after that you can import it. Next, we need to initiate the video capture. In brackets we add 0 plus cv2.capdshow. Most of the time your camera will be auto-detected using 0, and that should be enough. Next, knowing that video is just a bunch of images or frames, we need the while loop to go through them. We write while true and in it underscore comma frame equal to cap.read, so it will read all our frames. Also add one more line to rotate my video by 180 degrees. Use this line if your camera is rotated 180 degrees like mine. Next, we need to show it. For that, we write cv2.imshow, and in brackets we add window name image, and what we want to display, it will be frame. What's left is to add a couple of lines, which will help us to close the window and stop the code. We add this line to close the window when the escape button is pressed. It will break the loop. And we finish by destroying all windows. We can test the code. Okay, there are no errors and we can see the camera video. Let's move to the next part. In this part, we will write the code to select a color from our frame. This is how we will identify our object's corners. We also will create two more windows. First, to help us track what color we are hovering over with our mouse pointer, and second, what color we selected. For that, we will need another library NumPy. You will need to install it. Let's import the NumPy library as np. Next, let's create our mentioned two windows. We use NumPy zeros, and in brackets we define shape 200 by 200 and 3 to store all 3 color channels. Next, we need to have a named window because we will use the MouseCallback function. The name must be the same as our main window where we are showing our frames. And after that, we can use the setMouseCallback function, which sets the mouse handler for the specified window. We just need to define the name of the window and the callback function for mouse events. Let's name this function selectColor. This function will grab the coordinates of the mouse pointer and also the color of various coordinates. The MouseCallback function has 5 parameters: event, x and y coordinates, flags, and user data. We'll be using just the first 3, but the function to run needs all to be defined. Next, we unpack BGA channels at the x and y coordinates of the mouse pointer to separate variables, and change the color in the color search window to this color. And for the next window, we use event type. If event is equal to cv2.event left button down, we change the color in color selected window to selected. What's left is to go to the main while loop and add these two windows, color search and color selected. Now we can test it. When we are hovering over different colors, color search window shows that color, and when we select, the color appears in the color select window and stays until we click on another color. Let's go to the next part. In this part, we will create a mask for the selected color. It will help us later to detect the contours and draw centroids. First, let's go to the main while loop and convert the frame's color space from BGA to HSV. It will help us easier to detect the color. One color objects in different lighting have different shades of color, so the next thing we need to have is a range for color selection. For that we will add two lines, lower HSV and upper HSV. It will create NumPy arrays with our color range. We will add range just to hue. Saturation and value we will define as default values. Hue we will get from our frame and create a range by subtracting and adding 5. Saturation will have values from 50 to 255 and values from 20 to 255. You may need to adjust them depending on the lighting conditions and used camera. Next we will create a mask using enRange function, in brackets via source, lower and upper boundaries. What's left is to get the hue value. We go back to the select color function, and when we press the left mouse button we can grab the hue value. We run hue equal to HSV, square brackets with x and y coordinates, and another square bracket with 0 index to get the hue value. Also we need to make this hue variable global, because we need to access it outside this function. We finish by adding the starting value 0 outside the function. In the main while loop, we can add another ImShown line with our mask to see how it looks and run the code. We select the color and we can see how the mask is working. If your result is not so good, first try to improve the lighting, and after that adjust the HSV range. In this part, we will draw contours for our selected color objects. For that, we will create a new function. Let's add some space after the select color function and add the search contours function with the input mask. Let's write contours comma hierarchy equal to cv2.findContours, and in brackets we add a mask, contour retrieval mode, and contour approximation method. Next, we can draw the contours using the for loop. But before actually drawing the contours, let's filter them by size. We calculate the contour area and assign it to the area variable, and after that we add an if statement with area boundaries 1000 and 10,000. We finish by adding the draw contours function, cv2.drawContours, and in brackets let's add frame, contour in square bracket we want to draw -1 to draw all contours, contour color green, and contour thickness 2. What's left is to go to the while loop and call the search contours function with the input mask. Let's comment the mask window and run the code. Let's try selecting the yellow color. Okay, we have all yellow objects detected with green contours. The same goes for blue, red, and orange. In this part, we will calculate and show centroids for detected color objects. Let's move to the search contour function. We will find the centroids by calculating the moments. The moment is a particular weighted average of image pixel intensities. Centroid coordinates cx and cy we get by converting image to binary format. And to prevent the error of floating division by 0, we add the if-else condition. We finish by drawing the white circle on our frame to centroid coordinates. Let's run the code and see. Okay, we have centroids. Now we can go to the next parts where we will connect with centroids to make the triangle and calculate geometry parameters. Okay, we have centroids as our triangle corners. Let's mark them with capital letters. We also need to be aware that the triangle needs exactly 3 corners, no more and no less. So we need to track how many corners we have and run triangle calculations when we have 3 corners. So let's start by storing centroid coordinates and counting how many centroids we have. First, let's create an empty circles list to store the centroids coordinates. Next, we go to the search contours function where we count contours and gather centroid coordinates. Here we add the starting contours count equal to 0, and after drawing the contour, we increase the contour count by 1. After centroids calculation, we can add centroid x and y coordinate pair to the circles list. We finish by adding the return statement to return the contour count when the function is called. So we add count equal before search contours function is called. Now we can add condition in which we define the triangle calculation is only run when we have 3 corners. If count equal to 3, triangle calculation, and in brackets we add all 3 corners coordinates. Else we just do nothing, pass. And knowing that in a while loop, the function will be called every frame we need to empty the circles list before running the next iteration. Let's move up, and before the search contours function, create the triangle calculation function with the input of 3 corner coordinates pairs A, B, and C. First, we will show corner names A, B, and C. We access corner coordinates using list slicing, square brackets with 0 x coordinate, square brackets with 1 y coordinate, and we offset them by 10 pixels to the left and up. What else we need to do is to define the font. Let's move up in the code and add a font equal to cv2.font Hershey simplex. Okay, now we can test it. As start, we already have 1 point, but there is no corner letter because it's not enough for a triangle, so that's good. If we select the yellow color, we have 4 points, and that's too many. With orange the same as with red, and with blue it's working. We have 3 corners and letters to them. And that's it for this part. Let's move to the next one, where we will calculate the triangle's angles. Here we will start using some math. So we will need a math library. Let's import it. We will calculate angles from cosine law. And for that, we need to calculate the square distance between neighboring points. Let's add the length square function with input x and y. X is 1 point and y is another. Now we can move to the triangle calculation function and calculate the square distance between points B and C, A and C, and A and B. Next we calculate the length between these points, and finish calculating the angles from cosine law. What else we need to do is to convert the angle radians to degrees. Now we can show these angles as we did with corners. For displaying the angle, we will use the format method to control how many decimal digits we want. For now, we will start with no decimal digits and we will use pink color. Let's test it. Okay, we see the pink angles. The corner points are a little bit moving, but we have a correct 180 degrees of all angles for a triangle. Let's connect the triangle's corner points with lines. For that, we will create a new function, connect circles. Our input will be count. For the line, we need a pair of points with their coordinates. We will get these pairs by using a double for loop and incrementation in a range to not connect the point to the same point. And we will store these pairs in a new list called lines. Okay, now we need to go to our main while loop and draw these lines. We will move our triangle calculation with if-else conditions in for loop. For point in connect circles, in brackets we add count. And we draw the line cv2.line and in brackets we add frame, point 0 for x coordinate and point 1 for y coordinate, white color and thickness 2. Let's run the code. All corner points are connected. Now let's show the distances on the triangle's edges. We already calculated them via here. We just need to display them. And it would be great to display these numbers in the middle of the edge. For that we need to calculate the middle point coordinates. Let's go up and create a new function named middle calculator with input x and y. It will be 2 points with their coordinates. To find the middle point coordinates is very simple. We add together x values and divide them by half to get the middle point's x coordinate, and add together y values and divide them by half to get the middle point's y coordinate. We finish by returning the middle point x and y coordinates. Now we can go to the triangle calculation function and calculate the middle points between AB, BC, and CA. And after that, we can show edge distances or lengths. For A edge, it will be BC middle point, for B, CA, and for C, AB. Let's run the code. Okay, we see distance values are in place, but they do not represent the real measures. We will correct this later. Now let's move to the next part, where we will calculate the triangle's perimeter and area. To calculate the triangle's perimeter and area is quite simple, we just need to use the right formulas. First, let's define the starting values for perimeter and area. Next, we need to go to the triangles calculation function and make these variables global. After that, we can calculate the triangle perimeter, which is just the sum of all edges. To calculate the area, knowing the length of all three sides, we can use Heron's formula. For that, we need the half perimeter, and after that, we can write Heron's formula. Okay, what's left is to show perimeter and area values on the screen. Let's go to the end of the main while loop and add 2 text lines. Let's see the result. Okay, we can see the perimeter and area. It's time to adjust the scale to get the real dimensions. In this part, we will add functionality to calibrate the scale to get the real dimensions. For that, we will use the MouseCallback function. We will put a measured length object on the scene and compare it to the length we will get from the code. A multiplier to get these measures even will be our scale. First, let's create a measuring system using the MouseCallback function. What we want is to measure an object using the right mouse button. When we will press the right mouse button at the beginning of the measuring object, we will grab the starting coordinates, and when we will release this button at the end of the measuring object, we will grab the endpoint coordinates. Knowing these points coordinates, we will calculate the line scale and indicate that the scale is defined. Let's make new variables global. We also need to add the starting values. For start and endpoint coordinates we define none, for line scalar 1, scale defined we make false, and true distance 10 cm. Now we can create the scalar function. We get the scale by dividing the true distance from the measured object distance. So what we need to do now is to go to the triangle calculation function and scale all edges by multiplying with our calculated line scalar. The same we need to do in triangle perimeter calculation and triangle area calculation. Also, now we need to show scaled edge distances, so we change that too. We also can change our number format by showing one decimal place, for perimeter and area too. We finish by adding the scale value to the screen. We will use if conditions. If the scale is defined, we show the scale on the screen, else we show that the scale is not defined. And that's it. Let's see the result. We select the blue color. Okay, we have a triangle with all dimensions, perimeter and area. And we can see that the scale is not defined. Now let's use the right mouse button to select the start of our measured 10 cm length object and release the right mouse button at the end. Okay, we can see that the scale is defined and all measures changed. The perimeter and area now look better. In the last part, let's add one more functionality to the code. We saw that defining the scale wasn't very easy because the window is very small. Let's add a zoom window to make it a little bit easier. Let's create a new function called zoom. We will need an image and a zoom factor as inputs. First, we will crop the image using slicing, V means vertical dimensions and H horizontal. And after that, we will zoom the cropped image using the resize function. We finish by returning the zoomed image. Next, let's add new starting values for H0 and V0 and H1 and V1. As you can see, our zoomed window will be 200 pixels by 200 pixels. Now we need to add an event type to make the zoomed window follow our mouse pointer. So we need to update H0, H1 and V0, V1 variables according to the position of the mouse pointer. We also need to make some boundaries for zooming because we can zoom outside the image. So let's add an if condition where we will limit where zoom can be done. We will pad our image by half of the zoom size, 100. After that, we can add another condition where we use event mouse move. So whenever we move the mouse, we will grab H0, H1, V0 and V1. Okay, we have image height, width, and h0, h1, v0, and v1 variables which we need to make global. Now we need to get the image width and height. Let's move to the main while loop and extract height and width from the frame using the shape method and list slicing. Okay, what's left is to call the zoom function with a defined frame and zoom factor. Let's also draw a circle in the zoomed window center to have a target point and show the zoomed window. Now we can test it. Okay, zoom works and it stops if we are too close to the boundaries. Let's select the blue color. We have a triangle. Let's define the scale. Now we can clearly see the measured object's start and end. This is how simple you can measure and calculate the object's dimensions and geometry parameters using OpenCV. Hope you liked this video. If you have any questions, leave them in the comment section. You will find the code in the video description. If you liked this video, please leave a like and hit the subscribe button for more Python videos.